Good morning, dear students. Let us start today the chapter 1, that is relation and function. This is chapter relation and function. So before starting this chapter, I'll recall one thing, that is set. We studied in the last year in class 11. What is sets? We will see that set is nothing but it is ordered pair, or it is ordered collection. Say that particular thing that is defined, and that defined things we are putting that together, that will be known as ordered collection. For example, set of vowels in English alphabet, or that is ordered collection, a particular things that is very well defined, so that is known as ordered thing. Also we can example it. For example, A, that is A, B, C, and set B is given as 1, 2. Here it is defined as set A is A, B, C. Whenever we are writing a small letter, that means this is nothing but the elements, and this capital letter, it denotes the set. So we have studied these things. Now the next thing is Cartesian product of sets. We have studied this also in the last year. Let A and B are non-empty sets, then AB, that A belongs to, then ordered pair is defined as AB, where A belongs to A and B belongs to B. This symbol is known as belongs to, and the symbol this is does not belongs to. So remember this belongs to means that particular set contains that element. Okay, so ordered pair AB is defined as A cross B, and it is written in the form of like A comma B, such that A belongs to A and B belongs to B. The ordered pair is defined likewise. And also we can say that, or note down that remark, that is first one, B cross A can also be defined as B comma A, such that B belongs to B and A belongs to A. So in relation and function, first of all we should understand those things. Ordered pair, this is ordered pair. We should understand these things, that A cross B, therefore we can say element A that is from A and element B that is from B, and we are making such pair, and this is defined like this. And also this is such that this symbol is represented as such that, and this is also a line which is represented as and said to be as such that. So let set A that is defined as 1, 2, 3, and set B that is defined as A, B. Then we can say A cross B is equal to, there are there are combination of that two, so it can be 1A, 1B, 2A, 2B, 3A, 3B. It is like that. A cross B is equal to that. B cross A can be defined as A1, A2, A3, then B1, B2 and B3. A cross A is defined as itself 1 1, 1 2, 1 3, then 2 1, 2 2, 2 3, then 3 1, 3 2, then 3 3. Then B cross B can define as A cross AA, AB, BA and BB. These are the elements which we are getting by Cartesian product of sets. And also note down that A cross B is equal to empty set if A is equal to empty set or set B is equal to empty set. If one of these two things are empty, therefore the resultant definitely we will get A cross B as empty. Now relation. We'll come to the topic relation, and that is we'll see let A and B be two sets, then a relation R from set A to set B is a subset of A cross B. Thus, R is a relation from A to B, and that implies on both sides R is a subset of A cross B. So also mathematically we can represent relation R from A to B is a subset of A cross B. Please make a note also that if R is a relation from, if A is not equal to empty set and B is not equal to empty set, that means this is non-void set, and also A, B that belongs to relation R, then ARB that reads as A is related to B, A is related to B by the relation R, reads as A is related to B by relation R. If the next point, if A, B does not belongs to R, then A is not related to B by the relation R, A is not related to B by relation R. So one should very much careful about these symbols. It is very important one. Next, if point number 2, if n of A is nothing but number of elements in set A is equal to, let us say, P, and n of B, that is number of element in set B, is Q, then there will be total number of element in A cross B is equal to PQ, and that is nothing but PQ is nothing but ordered pair. We are getting ordered pair, and relation from A to B can be given as 2 to the power PQ. This is very important one. One should know this all these details. Now let us consider the domain. So if R is given as A comma B such that A belongs to A and B belongs to B, then domain of R can be written as A such that A, B belongs to R, means elements of set A is known as domain. Clearly, domain of R, that is subset of A. Domain of R is subset of A. Definitely. Why? Because we are getting the subset of A only here. Let us consider an example. Let A is equal to 1, 3, 5, 7 and B is given as 2, 4, 6, 8, 10 and relation R is given as 1, 8, 3, 6, 5, 2, 1, 4 is relation from A to B, relation from A to B, then domain of R can be given as 1, 3, 5, 1. So elements are not repeated, therefore 1, 3, 5. Now coming to the next point, that is range. In a relation R from A to B, relation R from A to B, range is defined as range of R can be given as B such that A comma B that belongs to relation R. So further we can write in the above example that in this example we can write range of R, that is second element of the relation, or I must say elements of set B, that is 8, 6, 2 and 4. This is known as range. Here we are considering this second element, this 8, 6, 2 and 4. So we have written over there same. And as we know, range R is a subset of B, set B. Now coming to the next point, that is relation on set. Set A be a non-void set, then a relation from A to itself that is a subset of A cross A is called a relation on set A. Further, we'll go for types of relation. In types of relation, we will understand that there are so many of types that relation can be defined, and using those parameters we'll understand what are the types. So first one, void relation. What is void relation? We will understand that. Let A be a set. Let A be a set. Types of relation. Let A be a set. Then phi, that is subset of A cross A. Definitely this is defined as, that is a null set, that is also a set of that is a subset of A cross A, and so it is a relation on A. This relation is called the void or empty relation on set A. Means whatever the relation you are finding, there is one empty set is there as a subset of A cross A. So that empty set is known as void or empty relation on set A. This one. In other words, the void relation from